look at something. The first thing you're going to do for me now is to ensure you don't skip any part of this video. Don't skip any part of this video in order to get the full details, get everything about this class, the full class, so you're going to get it. And ensure you have subscribed to the channel. If you have a YouTube account, please just register and subscribe to this channel. As our subscription is going on, we have the energy to do more videos. Please subscribe. It's free to subscribe. Subscription is free, very free. You're not going to pay anything for it. Just click on that subscription button that is up. No, you are not registered. You are not registered with YouTube. Just register with Valid. It's a very simple procedure to just take. Just a good step. You're already there. So please ensure you have subscribed in order to something like know that we are already moving forward in the channel. God bless you as you do so. So today we are going to be looking at how to solve these problems. We have two equations, but we're looking for the y over the x. I'm going to differentiate y related to x, but y and x are two separate equations. That's an example of a parametric equation. But both of them must be linked together with a single variable called a parameter. Like this t now and this t is linking both x and y together. From that place, we can get our x out and the y over the x out of the question. How? Look at how it is done. Division. The first thing, we are going to differentiate both equations separately. We're going to differentiate both equations separately. So we have the first one is that y is equal to 3t squared. So that's okay. Let's differentiate y with respect to t. Because t is the y is a function of t there. So we're going to differentiate y related to t. So to differentiate 3t, we're going to have 6t, which is 2 times 3, that is 6. Then let me just do so that you see it in case you okay, it will be 2 times 3, that's 2 times 2, then 2 minus 1, that's 6t. That's 6t. You know how to do that. We have been following up with our video. Our first video, we have already done video on the how to differentiate polynomial function. The function is when you have a variable carrying power, a constant power. But if the base is constant and the power is a variable, it's exponential. We have done almost everything. So you can look at those videos. It's still the same channel. So we have already done the y over the t. Now let's check for x. The second equation, 2t, that is the second equation. So let's also differentiate this x in order to the function there, which is t. The x over the t will be equal to, so differentiate 2t, differentiate 2t, the answer will be 2. The answer will be 2. Remember, we differentiate ax, the answer will be a. Just the same approach. So therefore, dy over dx will be equal to, now two ways. It's either it is equal to dy over dt, then divided by dx over dt, or dy over dx can also be, or dy over dx will be dy over dt times dt over dx. Any of them is possible. So that you use this or use this. Now, what is dt over dx? Now, dt over dx is actually the reciprocal of dy over dx. Reciprocal means take the denominator to the numerator and bring the numerator to the denominator. That is the meaning of reciprocal. So, like this. Let's say if this one is any single good number, any whole number, or any number at all that exists is always divided by 1, but we don't put it there. Since any number divided by 1 still remain itself. So you can see this one is over 1. Then if I take this one up, I bring this 2 down, that is what we call reciprocal. That's 1 probably 1 over 2. So this is the reciprocal of this. So you just take the reciprocal of the dy over dx, or then interchange the denominator and the numerator, and you have the x over dt. So if you want to use this, you already have the dx over dt. So let's try the 2 and see what we're going to have. Dy over dx, using the first one will be, what is the dy over dt? Our dy over dt is 60, that is 60, over, what is the x over dt? The x over dt is equal to 2. Now give us 2 here, 1, 2 here, 2, that is 3, 2. So that will be our dy over dx. So we can also use this as well. That's why I use this other one. Or dy over dx will be, well, dy over dt, that is 60 times dt over dx, that's 1 over 2. So that will be equal to, so if you have a whole number like this multiplying the fraction, the whole number will only multiply the numerator of the fraction, only. So that will be equal to 60 times 1, that is 60 over 2. So that will give us 2 here, 1, 2 here, 2. So that's 33, 2. You see both of them, but this first one is faster. That first one is faster. So that's how it is done. So let's look at another example, example 2. Let's look at another example 2. Example 2. That's okay. If y is equal to sine theta and s is equal to cos theta. If y is equal to sine theta and s is equal to cos theta, find dy over dx. To find dy over dx. To find dy over dx. So what will be the dy over dx to this problem? This problem. So, and they can also ask you. They can say 1 this. They can also say okay, number 2, find the square y over dx squared. Now that is from successive derivation. It means you should differentiate the over ds again. That means differentiation twice. That is the second order derivative. It means you differentiate it again. This is the first one. Differentiate the over ds again. You have the square y over ds squared. So let's try and look for the 2. Our y is equals to sine theta. Then if you differentiate this, the y over the theta will be equal to cos theta. That's what we have. Then our s is equals to cos theta. Then if you differentiate this, the x over the theta will be equal to minus sine theta. So from this first approach, dy over dx can be said to be dy over the theta divided by the x over the theta. So that we'll be having what is the over the theta? The over the theta is this cos theta over what is the x over the theta? What is the x over the theta? Or the x over the theta is equals to minus sine theta. So everything will be minus cot theta. Why? Because of this minus sign here, because minus sign here. Cos theta over sine theta is equal to cot theta. Equal to cot theta. In case you don't know, from trade identity. So the square y over the s square will be equal to. Now look at how you do the square over the s square, which is the second question that was asked in this second problem. What will be the square y over the x squared? Now, look at it. There's a problem here in the sense that we want to differentiate this is the dy over the x, this is the y over the x. I'm having this. Then, the square y over the x squared now will be, look at it. We cannot, look at this theta here. I want to differentiate dy over the x with respect to s again. That's what we want to do. The square over the x means differentiate dy over the x with respect to x. That's the meaning. Because we differentiate this with respect to x. So how are we going to do that? Look at how it is done. Look at how it's done. I'll give you a model to do it, or a very good method to do it, so that the thing will be very lovely. You cannot say differentiating this. You know, if you differentiate cos theta, the answer will be minus cosec square theta. Minus cosec square theta. That will be the answer. Minus cosec square theta. You have to differentiate tan theta. The answer will be sec square theta. Differentiate cot theta. The answer will be minus cosec square theta. So you cannot say, okay, I want to differentiate this one now. The answer will be minus cosec square. No. It's not possible because this is theta here and we are differentiating with respect to s. You cannot differentiate theta with respect to s directly. But we cannot say it's a constant will be 0. No, because theta is a parameter that links both x and y together. So I'm going to do it, guys. You are going to differentiate the dy over the x, which is called theta, with respect to theta, and multiply the derivative you are doing with d theta over dx. Now, why are we multiplying with d theta over dx? We are multiplying with d theta over dx in the sense that if we multiply this with d theta over dx, d theta and d theta will cancel out. Look at this. This will cancel this. Everything will now be d of dy over dx. Remember, dy over dx is minus cot theta. That's dy over dx. So this will now be d of what? Dy over dx is minus cot theta. If this cancel this, then everything will now be over dx, which is equal to x, equivalent to that. So that's how it's done. So you just differentiate your dy over dx and multiply the answer by the inverse of dx. By the inverse of dx, or the reciprocal of dx. Reciprocal of dx or the inverse of dx. The inverse of dx. So that we'll be having this. Now let's differentiate this. We're going to have, but there's minus here. Differentiate cos theta, we're going to have minus cosec squared theta. That's what we're going to have. The times, what is d theta over dx? D theta over dx. Now, dx over theta is equals to minus sine theta. Now, d theta, I already explained that over dx will be the reciprocal or the inverse of this. Taking the reciprocal means it will now be minus 1 over sine theta. And this can also be minus cosec theta. Why? Because 1 over sine theta is same thing as cosec theta. Cosec means inverse of sine. It means sine inverse. When you take the reciprocal of sine, which is 1 over sine, you're going to have cosec. That's what we're going to have. So we can also call this dx. So that this d theta over dx will be times minus cosec theta. So what are we having? This will cancel this. Minus times minus will be plus. That will be cos sec square theta times minus cosec theta. That will be equal to cosec square theta times minus cosec theta. That will be cosec cube theta. Answer. That is this minus here because minus will still be shown. So the answer will be minus cosec cube theta. Because cosec square times cosec, that will be cosec raised to power 3. That's what we are going to have. So please ensure you study it very well and then shout out questions from different textbooks that you have and put your questions on our comment section. That will know how to improve the channel. So we have done just 2 questions. You can see everything is already in place. These are question 1 and these are question 2. So please ensure you study it and give us your question. God bless you.